So now we move from factoring to applications of factoring, in other words, word problems. And we're going to do all these in one variable. And we can probably do a few of these in two variables later, but for right now, we're going to deal with one variable so we can use our factoring. So let's start with this one. We got to find two integers whose difference is 3 and whose product is 88. Well, again, with all word problems, I want to basically outline things. So I have number 1 and number 2, and then I want to write expressions for each one. If I don't know either, I call one of them x, and I know the difference between these two numbers is 3. So I could either say the next one is x plus 3 or x minus 3. It really doesn't matter because their difference is a total of 3. I'm going to go with plus. And then it says their product, which means if I take and multiply them together, that is going to equal 88. And so now we've got an equation to work out. Notice I distribute and get x squared plus 3x equals 88. When we're solving a quadratic, we need to set aside equal to 0, so we can use a zero product principle. X squared plus 3x minus 88 is equal to 0. Need to find two things that multiply to negative 88, add to 3. That's 8 and 11. And I need that 3 to be positive, so the 11 will be positive, the 8's negative, and I get equal to 0. Therefore, x minus 8 is equal to 0 using the zero product principle, and x plus 11 is equal to 0. X equals either 8 or x equals negative 11. Now here's the deal. These two numbers don't multiply to positive 88, so what I have to do is plug back in to the equations up here to get my other pair of numbers. So if x is 8, then x plus 3 equals 11, and if x is equal to negative 11, then x plus 3 is equal to negative 8. So there's two answers, and those are the two pairs. Find two consecutive positive integers such that the square of the first decreased by 17 is equal to 4 times the second. So I'm just going to go through there again and prepare this. Got the first consecutive integer and the second consecutive integer, and I know the first one will be x and the second one is 1 away since they're consecutive. I need the square of the first. The first guy is x, so x squared decreased by 17 is equal to 4 times that second value. So again, quadratic, I want to keep this squared positive. I'm going to distribute this, so I've got x squared minus 17 is equal to 4x plus 4, set aside equal to 0, x squared minus 4x minus 21 equals 0, factor, and I get 7 and 3. 7's got to be negative, 3's got to be positive. So x minus 7 is 0, x plus 3 is 0, x equals 7, and x equals negative 3. Now, the problem stated I need two consecutive positive integers, which means I can just cross that out. So if 7 is the first integer, then x plus 1 is equal to 8, and I'm done. If it just said two consecutive integers, I'd have two different answers. So next, we've got a geometrical problem, and this guy wants to purchase a rectangular rug. It's got an area of 80, so I'm just going to take and draw a rectangle and go a is equal to 80. I can't remember the length, but he remembers that the length is 8 more than some number, and the width is 8 less than that same number. So assuming that number is x, we're going to say this is x plus 8, this is x minus 8. So then we're going to take and find the area by multiplying. We've got x plus 8 times x minus 8 is equal to 80. Therefore, this multiplies. There's x squared minus 8x and plus 8x is 0x minus 64 is equal to 80. I'll take and set aside equal to 0 since it's a quadratic. X squared minus 144 is equal to 0. So that's x plus 12 and x minus 12 because that's a difference of squares or perfect square factoring. So therefore, x plus 12 is equal to 0. X minus 12, excuse me, is equal to 0. X equals negative 12 and x equals 12. Now, it doesn't make any sense to have a value of a length or width being negative, so I can cross that out, which means I have the value is x, and we want to basically figure out the length and the width. So if I have x is equal to 12, I have a x minus 8 of 4 and an x plus 8 of 20, and 4 times 20 is equal to 80, so that should do it. So this next problem is pretty similar to the one we just did. We're looking for an area. The length needs to be 1 meter greater than twice the width, and the area needs to be 3 meters. So again, I'm going to draw out a rectangle. We'll say the width is x, the length is 1 more than twice the width, and the area equals 3. So therefore, multiply together, x times 2x plus 1 is equal to 3. 2x squared plus x is 3. I need to set it equal to 0 since it's quadratic. It's going to require an x method. AC value is going to be negative 6. B value is going to be positive 1. Two things that multiply to 6 and add to 1 are 3, negative 2. So let's start writing that out. 2x squared plus 3x minus 2x minus 3 equals 0. First pair has an x in common. Pull the negative out. Now we have a GCF of 2x plus 3. Pull the 2x plus 3 out, just like we've done in all of our grouping problems, and you're left with x minus 1. Again, let's go and solve these using the zero product principle. 2x plus 3 equals 0. X equals negative 3 halves. And x minus 1 equals 0, so x equals 1. Again, doesn't make any sense to have a negative value for a dimension. So I know x equals 1, therefore the width is 1, and the length is 2 times 1 plus 1 or 3. So the table's 3 by 1. More area. We want to double the area of a rectangular garden by adding a uniform strip or uniform width along each of the 4 sides. The original garden is 10 by 15, so let's do this a little neater. So I got a rectangle. Whoops, it's not a rectangle. I've got a rectangle like so, and I have another rectangle that is being created that has a border, if you will, okay, of uniform width around it. So what that says is it says this distance here is x, this distance here is x, this distance here is x, and this distance here is x. And originally the garden was 10 by 15. So the area was equal to 150 to start with. All right. And we want to know how wide that strip is. So we know a couple of things. We want to double the area. Double A is equal to 300 because the original area was 150. And now we need the new dimensions of this length and this width. So if I started with 10 and I tacked on this length here and this length here, I've tacked on an x and another x. So that's 10 plus 2x. Likewise, if this were 15 to begin with and I threw on an x here and an x here, that's 15 plus 2x. And now I'm going to multiply the length by the width and get the new area, which is 300. FOIL all this out. I've got 150 plus 20x plus 30x plus 4x squared equals 300. So again, I'll take and set aside equal to 0. Combining like terms first, let's go ahead and do that. So it's 4x squared plus 50x. And then subtract 300, that's minus 150 equals 0. So now I know, okay, I'm going to have to take and factor. I can use the next method, but what I'll do first is I'll make the numbers a little smaller by pulling out a GCF of 2. So I have 2x squared plus 25x minus 75 is equal to 0. The only thing I really have to factor now is this, so I'm going to use my x method. AC is going to equal negative 150, and B is equal to 25. Then I have to find two things that multiply to negative 150 and add or subtract to 25. And if I think about it, that's going to be 2, and then I'll go 30 and 5, with the 30 being positive and the 5 being negative. So this is 2x squared plus 30x minus 5x minus 75 is equal to 0. Group these guys. That's going to go 2x, leaving me with that x plus 15. Factor out a negative 5, and that's x plus 15 is equal to 0. So then I have 2 and factor out the x plus 15 because that's a GCF, leaving me with 2x minus 5 is equal to 0. Therefore, x will equal negative 15, or x is equal to 5 halves. Again, doesn't make sense to have a negative uniform width, so I cross that off, and my uniform width is 2.5. This problem's a little bit different in that they're tossing an object up in the air from the top of the building, and the height of the object is given by this equation. So they're actually generating the equation for you. You just have to interpret it. Okay, so in this case, t is time, all right, and the height is h of t, or once you plug in a t, it'll give you the height. So they want to know how high is the object after 3 seconds. Well, basically what they're asking for is they're asking you to evaluate h of 3, which is just negative 16 times 3 squared plus 160 times 3 plus 1200. So now we've just got to work that out. Popping that into a calculator, I get about, let's see, 1536 The second part of the problem is a little bit different. It says how long does it take to find out when the object hits the ground. In this first example, they gave you a time. In the second part, they're asking you to find the time. So they're saying that the height in the second part is 0. So it's not h of 0, it's h equals 0, and that's equal to negative 16 t squared minus 160 t, plus 160 t plus 1200. So this is going to take a factoring. Fortunately, 16 goes into each one of these. I'm going to pull out a negative because I hate factoring with a negative leading coefficient. That gives me t squared minus 10t, and that's minus 75. So now I have to find out two things that multiply to 75, add to 10. Not too bad. That's t minus 15 and t plus 5 equals 0. 0 can't equal negative 16, so I just cross that off. T should equal 15, or t should equal negative 5. Can't have a time in negative, so we've got 15 seconds for that to hit the ground. Drawing a picture is really helpful with all these word problems, as well as just taking time to read carefully and interpret what the problem's asking.